Hello, people watching this video. Wrestlers and I don't know who else is gone. And Haley and I don't know, wrestlers and Haley maybe. Okay, we're gonna start 5-3. 5-3 is a lot of story problems, but they're not that hard. They're not terrible. We just need to know the formulas. So this is the part, like 5-3 stuff, all of these formulas that we put off to the side here and like go through and write down. We're gonna put those on a note card eventually when we go to take this test, okay? So these are not things that you have to memorize. We're going to talk about them, talk about the variables and stuff. They use different variables than I do sometimes. So we'll go through and make sure all the variables are the same, and we'll write this down on note cards, okay? So applications of exponential functions, this is like story problems, okay? Compound interest, when it's compounded annually, actually looks like simple interest, okay? They have the formula for compound interest right here, and they are using the same variables as we do. So A is the after amount, if you need to write this stuff down in here. After, P stands for the principal or the starting amount. R is the interest rate, but we need to make sure it is written in decimal form, okay? Not in percentage. They will give it to you as percentage. You got to move the decimals. And T is in time, usually in years, okay? So T is time, usually in years, unless they specify otherwise. If they say months to begin with, you're in months, okay? So there is that. This is the formula for compound interest. Let's go up here to the top. If you invest $6,000, we just have to figure out where these things go. What is $6,000 representing? The starting amount, okay? So this is capital P, okay? 8% interest, that is R, but we're going to make it 0.08. Do you guys know how to convert? Two decimal places, right? Move it. Compounded annually. Don't worry about the compounded annually part. We're going to talk about later on how that's different, because here we're going to do compounded quarterly and monthly and daily and all those things, okay? Compounded annually, you don't have to do anything extra special, okay? How much will the account be at the end of 10 years? What are we finding? Which variable do we not know out of this formula? The after. We don't know the after, so we're just going to plug all the stuff in. 6,000 times 1 plus. Now, keep in mind that could be a minus also. I think we talked about minus on Tuesday. Minus would be if it's like depreciating in value. This one's going up in value. So 1 plus 0.08. And we're doing to the 10th power. Now, when you go to type this in your calculator, it wouldn't be a bad idea for you to like do this part in your head, right? What is 1 plus 0.08? Okay, that's going to save you a little bit of like a couple keystrokes on your calculator, okay? So practice typing that in. 6,000 times 1.08 to the 10th power. And the after amount should be something more than 6,000. I don't know. Like maybe like 8,000 or 9,000, something like that. I don't know. What? What'd you get? It might be huge. 10,000 something?
12,953.55.
5. Are we doing money? Yeah. Yes, so we want to do two decimal places, okay? Okay, so yeah, 8% interest though, that's pretty huge. Like you'll never find an 8% interest rate anywhere.
It's on a loan.
Unless it's on a loan and you're paying that, yeah, right?
Are we doing the full lesson today?
No. It will take us a while to get through these story problems, okay? So this is a formula that we will eventually end up writing down on a note card, okay? All right, good. That was compounded annually, okay? Here you go. I'm going to write down, I wish they would put this formula in here because we actually need this next. Compound interest that is not calculated annually, you can put annually here. A-N-N-U-A-L-L-Y, annually. That's the formula you want to use for annually, okay? Compound interest when it is not compounded annually, okay? When it's compounded quarterly or compounded monthly or compounded daily, and we'll talk about what those things mean, okay? Is slightly different formula. Write this down, okay? It's not on your page already, okay? So A equals P. We're still going to start out with that. And it is 1 plus R over N. We'll talk about what N is here in a second, okay? To the N times T power, NT power. This is the formula that you want to use for compounded interest, okay? All of the variables are the same thing, except N is the number of times it is compounded per year. Per year, okay? The number of times it is compounded per year. So, just FYI, when we were doing annually, what is N for annually? 1, okay? 1 time per year. So here's the deal. If I plug 1 in for N, What is r divided by 1? Like, what does this come out to be?
1, whatever R.
Just r, right? And 1 times t just comes out to be t. That's why the formula that they gave us in the box works, because you're just plugging 1 in for n. So you technically could use this formula for annual. It's just your n is 1, and so you might as well not even talk about the 1, right? Okay, because the 1 is not going to change things, okay? So this is the formula you're going to want to use for when it's compounded other than annually, all right? Here we go. So, all right. All right, let's go ahead and do these. Let's calculate these. What?
The n is always like a whole number then, right?
N is always going to be a whole number. Yes, 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 yes. Okay. All right. So annually, let's write down what our n's are. Annually, n is 1, or you could just use the other formula where you don't even have to worry about annually or your n. Quarterly, what would n be if you're compounding quarterly? 4. Okay. Monthly? We're just testing how many months are there in a year. Wow. What do they put for daily?
366.
They do
365
365. Nope. Yeah, technically there are 365 and a quarter days in a year, but they always use 365. So you get gypped on a day every 4 years, right?
Wow.
They only, even if it's on a leap year, they only ever use 365 just to keep it consistent. Otherwise the computer systems would be like off every 4 years or whatever. So they always do 365 for daily. Got it? Okay, always 365. All right, so there's that. All right, determine the amount that a $4,000 investment will be. That's my P. R is going to be 6.4%, but we put it as R equals 0.064. Yeah, if you move the decimal 2 places. Okay, for each compounding period. Okay. All right, so here's how this works. When you're compounding annually, quarterly, monthly, okay, what they're going to do is, don't write this down, but this is what this means, right? $4,000 is what I'm starting with. We're going to end up multiplying that by 0.064, and then you add it back onto the 4,000, okay? Got it? Okay, that's what that will look like, this process for annually. You're only calculating, you're taking your interest rate once, and you're adding it back to the principal, and that's the amount of money you get, okay? If you're doing it quarterly, this is what this means, right? Okay, you're going to take your $4,000, right? And you are going to multiply by a fourth of 6.4%, which is 1.6%. So I'm going to multiply by 0.016 because that is a fourth of the percentage, okay? All right, so at the end of the 3 months, at the end of the quarter, I'm going to multiply by that, get a number, and I'm going to add that back. And let's say it ends up being like $4,100. Okay, I don't know what it is exactly, but it's about $4,100, whatever. Okay, then what I'm going to do is at the end of the second quarter, I'm going to multiply the number, the 4,100, by 0.016, and then add that back. Okay, and I'm going to do that 4 times over the course of the year, right? But we should know, hopefully, that when you take a percentage of a number and then you take that same percentage of a larger number, it makes it slightly more. So compounding quarterly is going to give me, I'm still only doing 6.4% over the entire year, but I'm separating that into 4 pieces, and I'm taking 16 or 1.6% of a larger number each time in the subsequent quarters, right? So everything after the first quarter is taking that percentage of a little bit larger number. So quarterly should give me a little bit larger of a number than what annually would, okay? Monthly, we're doing that 12 times. So we're taking, that percentage of a larger number each time. So monthly should give me a larger number than quarterly even. Daily should give me an even larger number than that, right? Slightly, because you're doing it every day, but you're taking a percentage of the day before, not of the original, right? Okay, so that's how this is working. If you don't care to know that, whatever, just use the formula, but that's why these numbers are going to be different, right? Compounding quarterly, compounding monthly, it's just you're doing a different number each time, okay? The formula does it for you, okay? So we are trying to find the after amount. 4,000 is what we're starting with, okay? 1 plus 0.064. I can divide it by 1 if you want to use that formula, and then 1 times T is saying over, we didn't write out what T is. What's T? Over 3 years. I missed it because it's in word form instead of in like number form. Okay.
Read the whole problem.
What? I know. I have to read the whole problem. I'm not doing it. Okay. So again, we don't need that 1 there on the bottom. We don't need this 1 here. So if you just do like 1.064 to the third power and then times 4,000, what's that going to give you? after 3 years? Like 4,000 something. I don't know.
I don't know. What's 365 times 3? Anyone? 9, 12, 95?
Why are you taking it times?
What?
Why are you taking it times? You don't want to take it times.
I'm on a different.
I know, you don't want to take it times though.
Even if it's my power?
No, because t is still 3.
So if I
Oh. Yes. You're right. I'm sorry. Yep. I'm thinking when you're in the parentheses. Got it. Okay, what do you guys get for this one?
48.
For what? 0.20. Okay, so this is the amount of money that you would get back after 3 years at a 6.4% if you compound it annually. Okay, we want to compound it quarterly now. So the thing that's going to change is that still have 4,001 plus 0.064. I'm going to divide that by 4, which is 1.6%, if you want to just type that in or whatever. And then we have 4 times 3. So n is 4, 3 is my t. And you should get something slightly more than 4818. Okay, that's kind of a mess. If you need to calculate it in pieces, go for it.
This is commentary. What are we saying for weekly? Are we saying 52 or 52.?
52.
Just 52.
Yep, just 52. Yep. They always leave it as a whole number.
So what about like my pennies? Like none of my numbers came out with 2 decimal places. Do I round it up appropriately, or is it just you're out of pennies?
For your pennies?
Yeah.
What are you talking about?
So like you're doing quarterly, right?
What'd you get for quarterly?
I have no clue.
Okay. Anybody get a number for quarterly?
4839.32.
4839.32. Yeah? Yeah? So slightly more than that. Okay. Monthly.
4844.21.
Are you talking about like what happens to these decimal places after this?
Yeah.
Yeah. You just round accordingly.
Okay.
So you might get lucky and be rounded up, and then like that's good because whatever. But like you might end up having to round down. I don't know. You just round to the second decimal place. Okay, the next one, you're going to do the same formula again, but this time it's changed to 12. So if you have this all typed into your calculator and you want to just go back in and change your 4 to 12, hey, there you go. Okay, it just changed, the 4 changes to 12, and it should be slightly more than 4839. 48 something.
I just dropped a Cheeto down my shirt.
Okay, anybody got it? 48 something.
You're telling us that.
That's really great.
Anybody got this number?
44.21.
44.21? Perfect. There you go. That's monthly. That's 12. Okay? Then daily is the same thing. If you don't want to have to write the formula out, it's just the one right before it, but just change the 12 to 365. Okay? 365 times 3 equals like 48 something again.
4846.6.
Okay, 4846.60. There you go. Got it. Okay, so always, if you're using the same principle, same interest rate, same everything, you want to compound as many times as you can get. If they give you the option of whether you want to compound monthly or daily, you're going to pick daily if you're getting that money. If you're paying that money, you want to do the opposite, right? Okay, but if you are getting that money, you want to compound you want to compound per second if you can, right? Like if they'll let you go that far. Okay,
I'm sure
So-
they'd stop you at some point.
right? But take a look. Yeah, they will stop you at some point, and it's called continuous compounding. It's called PERT. So compounding per second, compounding per millisecond, you use PERT instead of daily or monthly or quarterly or whatever, okay? Now take a look at the differences between these two. There's a really big jump from annual to quarterly, right? That's like $21, just about, right? Okay, but then this one is only like a $5 jump, right? And then from monthly to daily is only like a $2 jump, right? Okay, so if we would do per second, it would only give us like maybe $1 more, right? Okay. All right, so we'll get to that, how it's, we'll talk about the number E and how we get to that point, okay? Good?
Is that it?
Example 3, if $5,000 is invested at 7% annual interest compounded daily, let's fill out our formula here. We've got 5,000 as our P. We want 7%, so 1 plus 0.07, and we're going to divide by how much? 365. Okay, here's the deal. This is the hard part. We got 365. We don't know what t is. We're trying to solve for t, and we're trying to figure out when that will become 6,800. So we get to plug and play for a little while, which is kind of unpleasant, but whatever.
Well, there is a $38 jump from yearly to daily in our above example, so I would guess, and that was for 3 years. I want to guess like 20 years.
20 years? Let's plug in 20 and see what you get. T equals 20. How much does that give me? 7% though, that's a big percentage. Maybe not. I don't know. What'd you get?
A big, big number.
What'd you get?
Like something to the 14th power.
Oh,
I
seriously?
don't know if I did it.
I got 20,270.
Okay, let's back off on our T. Let's go to like 10. Let's go to 10. So go back into your equation and just change your 20 to a 10. What does 10 years give you?
10,068.
10,068. 10,068, something like that? Okay. All right, so let's back off a little bit more. Should we go to how much? 8, maybe? Nah, let's go to like 5. Let's go T equals 5.
7095.
7095? Okay. All right, back off. Just like, let's do 4. What's the 4th year give you?
6615.
6615. Okay, so when will it be 6,800? Sometime between the 4th and 5th year. So I'm going to say between year 4 and 5. That's what we want. Okay? Between the 4th and 5th year, we'll give you $6,800. Hey, that's a growth of 1,800 though. In 4 and 5 years, you better believe if I can get that interest rate, I would love it, right? 5,000? You're like getting $1,800 of free money after 4 years. Huh, nice. Okay, good?
Yep.
All right, so we're just going to talk about this one. So this one here, this is like your little box right here. If they ask for annually is going to be 1, semi-annually or biannually is going to be your N being 2, quarterly is 4, monthly is 12, daily is 365. If they say hourly, you're going to use an N of this. Every minute, you're going to use this. 525,600 minutes. No? Nobody's heard the song?
Yes,
Oh my gosh. Okay, there you go. Every minute, every second, you're going to use this number for your N. So that's your little chart right there. Okay, now, we talked about how this number, the more we do it, the more we compound, the less it jumps, right? Like from here to here is only like a $2 jump, okay? Eventually, we get to a point where every second, every minute is not going to really give us too much of a difference, okay? So what we do instead is we do something called continuous compounding, which is the top of the second page, okay? And rather than doing every second and every minute and every millisecond and every fraction of a millisecond, we just do PERT, okay? Because using that letter E ends up giving us a number that is so close to like doing seconds and milliseconds and that stuff, okay? So we do PERT instead, okay? E is taking the place of the 1 plus R over N part, okay? That's what the E takes the place of. So it's actually an easier calculation doing compound continuously rather than like the regular compound interest, okay? We only have to type in E. But P stays the same, R is still the interest rate, T is still the time in years and all that good stuff, okay? So PERT takes the place of compounding like every second or compounding as many times as possible, okay? And they will say that you're continuous compounding, okay? All right, so let's practice doing PERT. This is example 5. If you invest $4,000 at 5%, okay, so this is your P. 5% is going to be your R, but we're going to write it as 0.05. Compounded continuously. They will tell you every single time how they want you to compound it, okay? This one's compounded continuously at the end of 3 years. That's my T. So A is the after amount. That's what we're solving for. P is 4,000. We do E, not, we don't have to do the 1 plus whatever. E to the RT power. Okay, R is 0.05. T is 3. Okay, do you guys all know how to find your E button? You might have to hit shift something.
Shift LN.
Shift LN, and we'll talk about what LN does later in the chapter.
Oh, found it.
Okay. And some of you guys, when you hit the E button, will already open up your exponent. And so you just have to type in like 0.05 times 3 or whatever. You don't have to use parentheses. You can write it as 0.05 times 3. Okay, if we compound it secondly or continuously, what will he give me? 40 something.
46, 47.
46, 47, point. 0.33. There you go.
4. Give me my
3,
penny.
4. Give you your penny. All right, he's going to get particular about his pennies. All right, so there you go. There's that. Got it?
Yeah.
Good? All right.
Wanna be done?
Let's do one more because this is also an exponential whatever thing, and then we'll stop at the next one, okay? All right, the world population in 1950 was about 2.5 billion people, and it has increased approximately at this interest rate. Write the function that gives the world population in X years where X equals 0 corresponds to 1950. All right, here's the deal. They don't tell me how it's compounding.
So it's X. It's continuous.
But people are continuously having babies all the time, right? So we're talking
I'm
about
not using
population.
every kid,
So this is going to be a continuous compounding function, all right? 1950 is year 0, okay? So we have A equals, what's P?
2.5 billion.
2.5 billion. All right, do we have to put all the zeros on the billions?
No.
No, you can leave it as 2.5. Just know that your A, if you solve for A, is in billions, right? Okay, so we can just leave it as 2.5 rather than putting all that stuff in. E to the, what's R?
Great.
0.0185.
0.0185 times what? X, yeah. They just want me to write a function. This is my function. Now we can go back through. If they were to give me a number for X or a year for X, we could plug in X, okay? So if they say 1960, what number are you going to plug in for X?
10.
Yeah, 10, right? Okay. The way that this equation is set up, X equals 0 is 1950. Okay, they just wanted the equation for it. Got it?
Yep.
Not to actually solve anything. All right, there you go. We'll stop there. Let me give you your homework and you guys can at least look at it maybe. Some of these are kind of long, so do some if you can. All right, there you go. Goodbye, people in the video.